Hello everyone, my name is Logan Mills and today I'll discuss Netflix's dependability, specifically the 2015 outage and the lessons we can draw from it. Netflix is a widely distributed service serving over 220 million subscribers worldwide and handles about 2 billion monthly users. Netflix is able to handle this traffic by using over 700 microservices. However, the distributed nature of the system raises other unique challenges in maintaining speed, consistency, and availability. Operating at Netflix's scale requires careful management of its complex infrastructure. The platform relies on hundreds of microservices that all come together to make the fast and highly available service work. Yet this architecture also introduces risks. Maintaining the separation of the services to prevent cascading failures can be difficult. Additionally, availability remains at the heart of Netflix's business model, meaning downtime could risk losing subscribers and credibility, especially with rising competition in the streaming market. Netflix also uses numerous database systems like CockroachDB, MySQL, and Cassandra, just to name a few. These databases are responsible for hosting different information. For example, the metadata for shows and movies are stored separately from the actual show streaming data and rely on different services, allowing them to choose the best system for their data needs. However, this introduces more dependability challenges with maintaining data integrity. One issue that underscored the importance of data integrity was an incident in 2015. In 2015, Netflix experienced an outage lasting around 45 minutes, affecting users worldwide. User reports of the outage started to flood in. The Netflix team quickly tried to analyze the issue and restore the service as quickly as possible, calling teams from different departments to try and isolate the issue and restore service to users. In an attempt to identify the issue, recent updates to the service were rolled back. Eventually, the data was reverted to a recent backup, which restored availability to Netflix and revealed that the error was within the data. While the backup was able to restore service, the team still needed to identify the cause of the system outage. It was soon revealed that duplicate objects were being created, leading to primary key duplication. Primary keys serve as the index of data in a database, and duplication means that queries are returning multiple instances instead of just one. This seemingly minor data issue led to cascading failures, causing widespread service disruption. The error eliminated the need for more validation of their data. However, some feared that monitoring and validating data would slow down service, causing more issues than would be solved. Today, Netflix utilizes a variety of testing techniques to validate the data in their systems. One of these techniques is the use of circuit breakers. By validating data before it reaches production, Netflix aims to catch potential problems early. Implementing integrity checks and duplication detection at every level helps identify and mitigate issues proactively. The point of these circuit breakers is to identify changes that exceed some threshold of expected changes. They highlight the importance of implementing knobs to change these values as needed. In the case that one of these thresholds is exceeded, the data will not be committed and there will be a notification to the team to more closely examine the data before completing the upload. Another strategy Netflix employs is canary testing, or red-black commits. This involves deploying changes in a shadow instance that mirrors production. Using real user data and interactions, they can observe and test new commits for errors without impacting the live service. If issues arise, they're isolated and can be addressed before wider deployment, preventing the impact of bad data on service availability. Netflix also uses a staggering strategy when rolling out updates. By incrementally deploying changes, they can monitor each region for issues before a full release. This staggered approach helps contain problems early, limiting their spread across the platform. Similar to canary testing, this allows Netflix to observe and isolate bad data before it can cascade into other systems, causing a wider outage. Perhaps the most significant lesson is treating data with the same discipline as code. Netflix's engineers now approach data with thorough testing, validation, and constant monitoring. Practices like chaos engineering, where they deliberately introduce failures to test resilience, help ensure their platform can withstand real-world challenges. In conclusion, Netflix's response to the 2015 outage illustrates a comprehensive approach to dependability. They recognize that preventing issues before they reach users is essential, and they've built a culture of rigorous data validation, cautious deployment, and constant testing. These lessons are valuable not only for Netflix, but for any organization aiming for high availability and reliability in these complex systems. These are my references. Thank you.